So the first question I'd ask, have you kind of evaluate for yourself is kind of what's the purpose of the data warehouse? Why are you kind of going down this path? Because for each company, each company's requirements, each company's profile, it's completely different. So, I'd ask yourself, what problem are you trying to solve? Is it really just you need end users to be able to do their own ad hoc querying of data? Is it really getting more transparency into the eyes and hands of management so they can kind of access their own data and their own reports, analyze their own information, and drill down through things? Is it consolidating data across different systems? Maybe you've got a large organization with 5 different ERPs or 2 different ERPs, or several different applications that need to be tightly tied together. So these are the questions you need to kind of do examine your specific organization's requirements to come up with, okay, here's what we really need to do. Is the data warehouse the best fit to accommodate that? The other thing is even if the data warehouse is the right approach, it's then the question is, okay, can you support it? And that's kind of where you need to evaluate what's your number, your IT staffing like, how many instances of JD Edwards do you have? What are the number of systems you need to integrate? What's your budget? Because these are all things that are going to roll into your decision of whether or not it is the right fit and will deliver the most successful implementation. So preferred strategy, we're agnostic here, based on the evaluation of an organization's profile as well as what they're trying to accomplish and what they're looking for a data warehouse to facilitate for them. We can help determine whether or not it's not only feasible but also the most logical direction for a company to go in. So the next thing is really what are the different layers, and so if you look at from a business intelligence standpoint, there's the back-end layer, and you're either going to connect directly to transactional sources, so it's referred to there as a direct connect. You can also feed data from transactional sources to another repository that's just dedicated to BI and reporting, or you can then kind of change the modeling and the structure of that data from the transactional sources into a data warehouse. And that's traditionally when you say data warehouse, that's it's some actually the approach that we've taken is kind of creating that star schema. That's the kind of argued as probably one of the best data modeling directions to achieve, if you can get to that. And what's the difference between a star schema versus Snowflake? We'll get into that maybe a little bit more when we get into looking at some of the back-end data here. But so the key there is, regardless of how you're connecting to data, if you're connecting directly to transactional sources, or mirroring that data, or actually remodeling and modeling that data, the key that a lot of people don't realize is that there's still a layer that sits between the end users or the business users or the BI users and the data, and that's still that semantic layer or a data model or a template. There's still something that where the data warehouse is really just another subset of tables. You've got dimensions and fact tables, and we'll get into more details about that. But there's still some place where you have to relate those together and build extra business logic for the end users to be able to build their own content. So just because you go with the data warehouse doesn't mean you can skip a whole semantic layer and the front-end BI tools. So it's through that semantic layer that drives a lot of what the BI tools, how they actually talk to any data and any data source. So if you want to build a report or an ad hoc query or build a dashboard, from the end user perspective, they may not know what is going to a data warehouse or what's going against the transactional data if that semantic layer is masking a lot of that from them regardless. It's kind of just where you're pushing off some of the business logic. So if we now add, if you're going down a direct connect approach, where you're connecting to the data stored in transactional systems, in the semantic layer, you're going to have to build extra business logic there and naming conventions, and some of the things that you may change in how you're going to model your data warehouse is now kind of pushed into the semantic layer to make it the end users be able to easily understand the data and the data sets so they can build their BI content. And the same thing for replicated data, because replicated data is, in essence, you're no longer connecting directly to the transaction system, yet the data is virtually the same or very similar, because you're not really in a replicated, you're not really modeling that data in any way. So there's still a lot of more business logic in the semantic layer with the replicated data as well. And then the data warehouse, again, the semantic layers, and for R, we actually put on semantic layer connected to direct transactional JDA data, replicated data, or data warehouse. It's very similar. So most users wouldn't be able to tell the difference of what semantic layer is connected to a data warehouse versus the end repository. Now, when you look inside that universe or that semantic layer, you can understand that there's differences behind the scenes, but with the output of that semantic layer, it looks virtually the same. But there is less business logic that can be taking place in that semantic layer on the data warehouse, because that's when you're modeling the data, you're kind of putting it into a format where you can reduce the number of joins, get into that star schema. This may make more sense as we get to those points in the demo. So really, what does this look like? If you've got, let's say, JD Edwards and other sources, with the data warehouse, you've got these transaction systems that people are entering data in all the time. Data is updated in there on an ongoing basis. So there's always ways to kind of customize different coding to populate a data warehouse, but pretty much in today's world, most companies are using some type of ETL tool to feed that data and create packages and transforms that are managed within a specific tool that's made for data warehousing. So you don't have to have coded SQL behind the scenes that's kind of unmanageable to the people that didn't build it initially. So basically, you're feeding data from your source, which would be, in this case, the JD Edwards, and other systems might be the source, and the target would be the data warehouse. And the ETL just grabs from a source and pushes to a target. That's really what extract, transform, and load is what ETL stands for. And that's really what you're doing, is just kind of feeding data from your source systems into that repository or data warehouse. And then there's a semantic layer that sits on top of that data set, and then you build your reports on top of that semantic layer. That's pretty much the way it works. So if you're going with a direct approach, in essence, you're going directly from these sources directly to the semantic layer and then up from there. So the question that you need to ask yourself is, can you go direct by itself, and then what about some type of hybrid approach? And that's something that in our world makes a lot of sense. If you're going with a data warehouse, and there may be reasons why you need to go with a 100% data warehouse approach, but for some reports, it might be nice to be able to run some of those reports, or do some analysis right on transactional data. An open purchase order report that might run in 5 seconds. Is there a reason to really push that, especially if you're only updating your data warehouse on a nightly basis? It might be convenient to be able to get some real-time data mixed in with some of the data that's pushed to the data warehouse for analysis on